we're going to be talking to y'all about unlicensed access and microwave fixed links in around the 60 gigahertz band. I'm Aiden O'Leary. I'm an electrical computer engineering student here at Olin College. I'm a senior.
I'm Alex Butler. I'm also a senior at Olin College studying electrical and computer engineering. To start off, we're going to look at the spectrum frequency schematic for this band. So at the bottom, we have the new unlicensed access band. And at the top, we have all of the incumbents. As you can clearly see, this is an in-band interference issue, which we're going to dive into a bit deeper. So to start off, we're going to look at the unlicensed access, which is the entrant to this space.
Yeah, so unlicensed access is spectrum designated as unlicensed or sort of free use by the FCC. So specifically in the context of this presentation, we're talking about the new 6 gigahertz band, more specifically 5.925 to 7.125 gigahertz allocated in 2020 by the FCC. This increases sort of available spectrum for unlicensed access by potential factor of 7. Potential use cases, and the two ones that we're going to be focusing on here majorly are Wi-Fi 6E and mobile cellular technologies, as well as some additional IoT capabilities. So first up is Wi-Fi 6E, the big one. So Wi-Fi 6E largely operates the 6 gigahertz band, which is higher frequencies, which means smaller wavelengths, which means you can pack more information into the same amount of time. However, this smaller wavelength signal has worse penetration and worse coverage. So Wi-Fi 6E will likely turn to mesh networks to avoid dead zones and other such issues. Additionally, the Wi-Fi 6E protocol includes provisions for OFDMA, or Optimal Frequency Division Multiple Access, which enables channel sharing among Internet of Things devices and subdivide channels so they can have more devices connected to the same network.
So next we're going to talk about 5G NRU. So 5G NRU is an emerging technology in the unlicensed spectrum space. So it's the operation of new radio, or NR, in the 5 and 6 gigahertz bands. Specifically, this is going to open up the 6 gigahertz band and enable 5 gigahertz support between existing technologies. It will support other channel coexistence mechanisms for enabling other radio access technologies, including LTE and LAA and Wi-Fi. So specifically what we're talking about here is that licensed spectrum and shared spectrum, which typically goes to bid and has an auction for it, is going to be combined with unlicensed spectrum to enable these kind of like cross-spectrum technologies for increased use. Specifically, what's interesting about this is that this is kind of seen as a competitor to Wi-Fi in a lot of regards, but it just does not have the bandwidth that can support the use that Wi-Fi has. So next, we're going to talk about microwave fixed links at 6 gigahertz. So these are the incumbents to this area. So what we mean by microwave fixed links is these services that have been here for a while, that are really reliable, that society just can't really go without, and they need to be up all the time. So what we're talking about here is broadcast auxiliary service, common carrier, local television transmission service, cable television relay service, and fixed link services. The two that we have in bold, we're going to dive into a bit deeper because they're kind of the meat and potatoes of this whole organization.
Yeah, so first up are common carrier services. Common carrier is a legal designation, specifically in this context applied to telecommunications carriers, which means that they are bound by law to provide fair service to the general population. This heavily ties into the net neutrality debate, which is far outside the scope of this presentation, but is worth touching on here. For the rest of this presentation, we use common carrier to refer specifically to the large backhaul networks that connect access points and core networks across the nation. These are significantly more effective and flexible than cable networks.
So fixed services in this band kind of encompass services established to maintain reliable shared infrastructure. So when you think of these services, they typically include the control and management of public utilities, such as electric power companies, public safety, backhaul for emergency and police dispatch, and backhaul for cell towers and long-distance telephone links. When you start digging into this, it's actually quite amazing. These systems have less than 30 seconds downtime per year, which translates to 99.999% reliability.
So in terms of a brief timeline of this issue, in the early 20th century, the FCC applied the common carrier designation to telecommunications industries, which sort of puts it under government protection and regulation. Next, in the latter half of the 21st century and the beginning of the 21st century, there's sort of this timeline soup as networking telecommunications become much more widely used, between phone services, radio, television, and finally internet. And this all leads to 2020, where the FCC allocates this new band around 6 gigahertz for unlicensed use, causing concern over coexistence. In 2022, which is this year, high-end phones and routers such as the one pictured here will begin to support Wi-Fi 6.
Yeah, so this leads into our proposed coexistence solution. So between the unlicensed access entrant and the microwave fixed links incumbent, the FCC has operated pretty well as a body to create a coexistence solution that takes into account the needs of the incumbent as well as the access of the entrant of unlicensed access. So specifically what we're talking about here is that these new technologies that we mentioned earlier have some pretty heavy stipulations about how they can be used and where they're allowed to be used. Specifically, automated frequency control systems, or AFCs, are required for standard power operations protecting incumbent spectrum. And limited to low power range mode has also been offered for Wi-Fi indoors. There's a lot around mobile operations and moving vehicles that kind of gets into the nitty-gritty about using the spectrum, which we can go into more of these questions, but we're going to kind of move away from that right now. And then an additional side note was that in the wideband and ultra-wideband will not garner special protections from unlicensed band interference. What this is saying is that even though you develop a technology for this unlicensed band, you can't kind of reserve spots in it to have unlimited use for yourself. You kind of have to take the noise that's with this channel as part of the use.
So more about automated frequency coordination. Outdoor Wi-Fi access points, or standard Wi-Fi 6E access points, must receive frequency and power maximums from a central coordinated automated frequency coordination system once a day. And this sort of ensures a maximum interference noise ratio of -6 decibels at these fixed length receivers, which is pretty good. And these systems use collected geographical data and transmitter data, as well as 3 different channel models, free space path loss, emitter 2, and irregular terrain, to determine what frequencies and what powers can be transmitted out without issue. We're going to go to free space path loss. The other 2 are outside the scope of this presentation. And AFC is notably only for outdoor standard power systems, as we'll discuss in the next slide. So I don't know about the laser, but the transmitter here is at the top left, and the receiver here is at the bottom, and then we have our Wi-Fi interloper as the Wi-Fi signal. And so the power received is the power transmitted, plus the gains the transmitter receiver, minus whatever free space path losses occurred. And then the power radiated out of the Wi-Fi, the effective isotropic radiated power, or EIRP, is the transmitted power plus the gain of the transmitter minus whatever path loss is there. So you'll see interference when these Wi-Fi access points are outdoors and potentially near microwave fixed length receivers.
And then we also wanted to include some information about FSS, or fixed satellite system, or fixed satellite service links, and indoor Wi-Fi. As mentioned by the FCC, there's no real concern about interference geometry between these two, mostly because of both the nature of indoor Wi-Fi having pretty heavy power stipulations, but it's also inside the building, and as we mentioned before, 6 gigahertz band really isn't made for penetrating these solid constructs.
Yeah, our opinion is that the FCC generally should be cautious and when it comes to adopting new technologies, because inertia is hard to reverse. And this effort should be sort of placed on the entrance typically. And that comes across in a specific case where the entrants need to develop and propose these AFC systems to protect the incumbents, the very important incumbents in this band. And this is bold. AFC is efficient and effective and pretty interesting. And generally unlicensed access should be unlicensed, and the FCC did a pretty good job.
Okay, that's our presentation.